basically mean at that point in time, equator would be receiving solar energy at the right angle. Then that means if equator is receiving solar energy at the right angle, all other places such energy would be spread across a larger geographical space. So now, because this is more direct, unlike this one which is spread across a larger geographical space, you would experience that the interaction between radiation and the Earth atmosphere would differ between the two places. The other important thing that you need to understand here is the difference between, for example, land and water in terms of how they interact with insolation. Just a quick example. Those who have been to Window or Katima, if you like, you would realize that during largely, for example, Window, you would realize that during summer, Window would get extremely hot. There's no doubt about that. But the same is true during winter. Window would get extremely cold, much more colder than Swakopmund. But some people that stay in Swakopmund would be complaining that Swakopmund is quite a cold place. During winter, I can guarantee you, Window could be -2 Celsius degrees. So it basically means the way in which insolation interacts with land is not the same way in which insolation will interact with water. So as a result, land will have a major difference between the lowest temperature and the highest temperature, whereas for water, because of this maritime effect, you do not have a large temperature range. So what happens? For example, during summer, when you have insolation coming in, hitting the Earth's surface, not water but land, basically mean such a radiation is not penetrating in the Earth's interior. As a result, it would easily be able to warm up the upper layer of the soil surface, so soil would be extremely hot. And there isn't any mixing taking place. However, for example, in terms of water, you have insolation coming in from the sun. Such insolation would penetrate deep down in the ocean. When it penetrates deep down in the ocean, now you would find that you would have cold water and warm water mixing up. So that, as a result, it would mean it will not be as warm as it is on the land. So that is the reason why you get to experience some different kind of subclimatic conditions between places that are found on land and places that are found much more closer to sea. The other important thing which you need to understand is what we talked about, and we already actually introduced this concept. We called it Coriolis effect. We said Coriolis effect is an effect that is brought about by Earth rotation. So this Coriolis effect is so important. It's so important because it is directly related to energy transfer. We already know how a molecule works. Molecules travel from areas of high concentration to areas of low concentration in order to reach some kind of balances. So it's pretty much the same here. You would have radiation moving from areas where you have net gain of energy to areas where you have net loss of energy. So now, coming back to Coriolis effect, we said in the northern hemisphere, objects are deflected to the right because of Earth rotation. When objects are deflected to the right, now things like oceanic circulation and atmospheric circulation in the northern hemisphere takes a clockwise circulation. Now, in the southern hemisphere, on the other hand, objects are reflected or are deflected to the left. resulting in oceanic circulation in the southern hemisphere taking a counterclockwise path. So it basically means, for example, just for Namibia as an example, we have what we call a Benguela current, right, of the western coast of Namibia. This Benguela current is considered to be a cold ocean. Why? Because you have a cold current moving from the South Pole all the way, moving from the South Pole all the way up to the western coast of Namibia. Then it moves up. When it moves up, it reaches the equatorial region. Now, when it reaches the equatorial region, it becomes a warm ocean, right? So it becomes a warm ocean. So it would continue with its counterclockwise circulation. Then when it will reach off the eastern coast of South America, now it's a warm ocean. That is why here you have a cold ocean. It would not rain. So we have a Namib desert there. It does not rain. Cold ocean does not bring about cloud formation and the rain. But now that it has turned to a warm ocean after having passed the equatorial region, so when it will reach the eastern coast of Brazil, it's a warm ocean, so it would rain. And that is the reason why we have the Amazon rainforest there. Whereas on the other hand here, off the coast of Chile, we have a desert. So what that tells you is that desert environments are directly related to where we have cold oceans. Look, Namib Desert, there is a cold ocean there is a cold circulation taking place. Chile Desert, there is a cold circulation taking place. Arizona Desert, there is a cold circulation taking place. There is another desert in Australia. There are a few exemptions, however, for example, the Sahara Desert. This explanation doesn't quite shed enough light on there. So again, this is the same thing with, for example, atmospheric circulation. So key for you to understand is that in the northern hemisphere, atmospheric and oceanic circulations are taking a clockwise path, whereas in the southern hemisphere, oceanic and atmospheric circulations are following a counterclockwise path.